All right. Yep, I'm going to go through it again, but I want you guys to try it. So stat, edit, enter this new group. Stat, one calc, one variable, statistics. All right. So let's look at what our new mean, new sample standard deviation, and new median are. All right, so I hit stat, which is right here by the arrow keys. I'm going to choose option 1 for edit. I see the 6 pieces of data that we had from last week. I'm going to arrow down, hopefully, to that empty spot at the bottom. So right here, I'm going to enter 80. You have to hit enter or it doesn't actually put it on the list. So until you see it show up in this list here, it does not count. So hit enter. You should see it on that list there. Now we're going to get it to calculate the mean, the median, the standard deviation, the sample standard deviation, all that stuff. You're going to hit stat again. Come on. You're going to arrow over to where it says calc. This is how you make it calculate things for you. I'm not hitting buttons. Okay. And we're going to choose option number 1 for one variable stats. So you can either press 1 or you can hit enter if that's what's highlighted. L1, that's the list that we put all of our information in. So L1 is what we want. So I'm going to hit enter. Frequency list, we don't have to worry about that. Calculate. There's my new X bar, my new mean. Here's my new sample standard deviation. Does anybody remember how to find the median on here? Scroll down. So choose the arrow key and head down. There's our median right there. Yep. Does anybody need me to go through those directions again? Because I'm happy to. All right, so let's go ahead and record these. New median is 18. The new sample standard deviation, SX, this is the one that I'm recording for our sample standard deviation, 23.99. What is standard deviation?
No, what is it on the calculator?
Sorry, SX. Sigma X, this one down here, is our population standard deviation. This would be if I had all groups of 3 AP statistics students ever. That would be my population. Since I don't have that, we just took a sample in here. We're using SX. And what was our new mean? I'm having trouble scrolling. 27.71. Awesome. All right, let me pull this up. There we go. So, how do these new measures compare to the original measures that we had? They're bigger. Is everything bigger? Which one changed the most? Mean changed quite a bit.
Standard deviation.
Standard deviation also changed quite a bit. What was our standard deviation before? Our sample standard deviation. That was our sigma x. What was the sample standard deviation, the SX? 7.266. Our old mean was 19. What was our old median? 16. Our new median is 18. So the new mean and new standard deviation. So the mean and standard deviation both increased a lot. Median went up, but not very much. Median only went up a bit. It went up 2 colleges.
Would it make it better if we say how much they increased by?
For the others, you can. So this right here, I'm probably not going to ask you this exact question, and I can't imagine that they would ask this exact question. What we're after here, though, with this particular question, is that we say that the mean and the standard deviation are non-resistant to outliers. So the mean and standard deviation are non-resistant to outliers. What do you think it would mean to be non-resistant? It's more easily changed, yes. To be resistant, it's gonna like not change much. Our median didn't change much. Our median would be resistant to outliers. The mean is non-resistant. It moves a lot more if we have outliers. If it's a high outlier, it's gonna get pulled up into those larger numbers. If it's a low outlier, that mean is gonna get pulled down lower. Think about for just a minute, let's imagine you guys get 100% on this first stats test. Everybody here gets 100%. Second test, we bomb it. We get it like a class average of 30%. What happens to the overall average if we've got 100 for one test and a 30 for the next test? Goes down. Do you think that that average, that mean, is a good representation of how well the class understands things? Not necessarily. That 30% on the second test would show that you don't really understand second test material very well. But if we wanted to know, like, how much does the group understand? The median is going to be much better when I'm looking at a group of data, if there's these outliers. So if we have these extremes, a perfect and then a failing grade, we want to more look at the middle, the median there, rather than the mean, if we want to know what's typical or expected. All right. Flip it over on the back for me. Big takeaways. The average, this is the official formula in statistics. This means for the mean, I'm going to sum up or add all of my x values, all of my data values. And then I'll divide by however many data values we've collected, which we use n to refer to that. Median is the middle value, or it's the average of the 2 middle values. If I've got an even number of data points and I cross out to get to the middle, and I have 2 in the middle, then I have to average those together. Measures of variability. We've got 3 measures of variability. We're going to talk about IQR here in just a minute. Standard deviation is a measure of variability, and so is range. Range is usually not going to give us nearly as much information as standard deviation does. And if you are asked to interpret the standard deviation in context, this right here, and you'll need this for your homework, talking about what does the standard deviation mean, you would say the, whatever context we're looking at here, so in our college example on the other side, the number of colleges applied for typically varies by, and then you'd give the value right here and add context. So 7.66 colleges from the mean of, and then you're going to give the mean here. And stick units. Anytime you are reporting numbers, you need to include units with those numbers. So if we're talking about colleges applied to, you would want to include that on the end of the numbers. All right? Yes?
So the X with the I at the bottom, does that equal like all of the numbers?
This one right here? Is that what you're asking about?
The X with the I.
The X with the I.
Yeah.
So xi, that refers to each data value, because every data set is going to have a different number of data values collected. So let me back up for just a second, okay? If we look back on the front page, each of these would be an xi. I could say that this is x sub 1, because that's the first group that reported their numbers. This would be x sub 2, x sub 3, x sub 4, x sub 5, x sub 6. Because if I did this same simulation with a larger class, I'm going to have more than 6 groups reporting. We're not going to put a number there when we're talking about overall formulas, so I is the thing that represents however many I've got total. And then each one would get their own little number assigned to it. Does that make sense? Okay. All right. We'll talk about interquartile range here in a minute. Mean and standard deviation are greatly affected by outliers. That's what it means for it to be non-resistant. Outliers or skewed distributions. You want to use the median and the IQR if we're talking about center and variability or spread. If we are symmetric or approximately symmetric, then you want to use the mean and the standard deviation. So when we're thinking SOX, shape, outliers, center, spread, variability, for those last two, the shape determines whether you go with the mean or the median, whether you go with the standard deviation or the IQR. All right? There is a problem for you guys to try right here. I want you to calculate the mean annual rainfall for these cities. You can do it by hand, or I can show you how to clear out your list in the calculator, and you can have the calculator do the mean and the median. So you can do this by hand, or you can use the calculator. In addition to the mean and the median, I want to know which one you would use to summarize the typical rainfall, and then I want you to interpret the standard deviation in context. I'm going to give you guys about 5 minutes to work on this, and then we'll compare your answers to mine. If you need help clearing out the list because you want to use your calculator, please let me know. I'm happy to show you how to do that. came up with and compare that to what I've got for these. Your mean should have come out to be 34.94. Median was 40.5. I calculated it out by hand. You did not have to calculate it out by hand. I showed it calculated by hand because I can't show the calculator doing its thing up here. But 34.94 inches, gotta have units. This is your context. They absolutely will hit you for not having context on these numbers. So get used to putting your units on everything. The median is 40.5 inches because we're talking about annual rainfall in inches here. I can also grab right here on that x-axis. That's how I knew they were measuring in inches. Any questions on that piece, whether you do it by hand or use the calculator? We'll continue to practice using the calculator. You guys will get much more comfortable and confident with that. All right, you should use the median. The distribution is skewed left. It looks like it might even have some possible outliers there. I'm going to go back and look at that picture and tell you what I mean by skewed left. If I trace over the top of this data, you see how it has this tail over here? And the tail is on the left-hand side. So this would be a skewed left data group. So we would use the median because the distribution of rainfall is skewed left. Interpretation of the standard deviation. The annual rainfall for a city, there's my context. This is what we're talking about here. The annual rainfall for a city typically varies by, this is the language that you want to use when you're describing standard deviation. It typically varies by 15.52 inches from the mean of 34.94 inches. So up in that box that said important ideas, this is that basic formula. We're going to have the context typically varies by standard deviation from the mean of, here's my mean. I've got context on both my mean and on my standard deviation, and I've got context right at the beginning of the sentence as well. Make any alterations to your own page that you need to. And then I want you guys to flip to the next page. And I want you to do the dot plot and the median for the data set that they give you there. There's a number line. I want you to create a dot plot. And I want you to find the median. Your dot plot should look something like this. Your dots might look slightly different than mine, but the overall shape and where the dots are located should look like this. There's one thing that is not on this dot plot that does need to be there. Does anybody know what it is?
57.
What'd you say?
57.
57. The number 57 wasn't on there, so yes, I did have to add that. Label. What is this a dot plot of? Heights. So I need to have that heights, and what unit are they using to measure those heights in? So inside parentheses, I'm going to put those units, inches. And does anybody have the median? 63, yes. Median was 63. Once you make that dot plot, you can cross off from both ends to get to the center. So like I'd cross 57 off with 77. I would cross 59 off with 72. 60 I would cross off with 70. Then if I'm coming from the left, I'm going to start at the bottom and work my way up. So I'd cross off the bottom one of 61 with 68. If I'm coming from the right and I'm crossing off, I go from the top down. So I'd cross off the top one of 61 with the top one of 65. And then bottom one of 62 with the bottom one of 65. Up 62, cross that off with the top of 64. Middle one on 62 with the bottom one of 64. Cross it off. I feel like I missed, oh, I did miss a point. I missed 71 back here. So right here, there's my median. What do you do if there's two dots that are in the middle? Add them and divide by 2. You average those two middles, only if it's an even number. So far, so good? All right. What is Q1 and Q3? Describe how you found them. Does anybody know what Q1 and Q3 stand for? Quarter 1 or quartile 1. This is the first quartile. Q3 is the third quartile. How do you find them? You put it in the calculator? You can absolutely do it that way. How do you do it if you don't have a calculator and you just have the raw data? Ty?
So like if you have the median, right? It's like the very first number to the median, that middle, and then the last number to the median in that middle.
Yes. First quartile, this is going to be the median of the smaller half of the data. The third quartile is the median of the larger half of the data. So I'm going to go back so that I can see that dot plot. All right, so if this is my median right here, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my median. So I'm looking, I did that backwards. These two should be switched around. Here's the median. That guy got crossed off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Nope, I had that right. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Everything to the left of the median. So I'm looking at this tall bar of dots and everything to the left of that. I'm going to find the middle there. Yes, Amy.
Okay, so when you say from the median to the first number, do you include the median?
Good question. That's a very good question. So In this case, because we had an odd number of data values, I will not include that one. If it's an even number of data values, so the median I've had to average, it's technically falling halfway in between those two. If I've had to average it, then I will like take one of the numbers that I use to calculate my median and it goes with the lower and the upper one goes with the upper. But that's only when you have an even number of data values and you've had to average those. In this case, that halfway point, that median, does not get included in my calculations for Q1. So I'm going to cross off again. So I would cross off 57 with the top one, 59, 60, 61. So right in here is where Q1 would be. How do I find that then? Add them and divide by 2. So I'd take 61 plus 62, cut it in half. That's how I get Q1. So what is our first quartile? 61.5. 61.5 is Q1. How would I find Q3? Same thing on the other side. So I'm going to cross off the 77 with the top one here in 63. I'm going to cross off 72 with the bottom one of 64, 70 with the top one. And I did it again. I skipped that one. I don't know what my problem is. 1, 2, 3, 1, 2, 3. One, two, three, four. 1, 2, 3, 4. So these two are my two in the middle. So how do I find Q3 then? Add them and divide. So we're going to add 65 and 68. Cut it in half. What is our Q3? 66.5. All right. So let's record our 5-number summary then. I'm going to come back over here. What was the minimum, the smallest number? 57. What did we say Q1 was? 61.5. What was the median? 63. Q3? 66.5. And the maximum, the largest value? 77. We're going to use this now to make our dot plot. Sorry, not dot plot, box plot. To make a box plot, I use Q1 and Q3 to make the left and right sides of my box. So 61.5 on the number line. That would be right here. 66.5 over here. I'm going to connect those together to make the box. So here's Q3. Here's Q1. The median should be inside your box. 63. Here's my median. Median, by the way, in case you were wondering, is also Q2. That's where Q2 went. That's why it's Q1 and Q3. Q2 is the median, but we normally just say median. And then I need my maximum and my minimum. So I should have a whisker coming off the left side of the box, should connect to the box and go down to my minimum value, which I'm going to go ahead and put on the number line again here, 57. And then my maximum comes off the right side, all the way over there. So here's the max. Down here is the minimum. This is called the 5-number summary: minimum, Q1, median, Q3, maximum. The interquartile range, IQR, is defined as Q3 minus Q1. So I'm going to take Q3, 66.5. I'm going to subtract Q1, which was 61.5. What would that give us? 5. This is my IQR. The IQR is the same thing as the width of the box. If you look at the number line down here underneath, if I go from 61.5 to 66.5, 1, 2, 3, 4, 5, it's 5 units longer, in this case 5 inches. That's what my IQR is telling me. This right here is 25% of my data. On the other side of the median is another 25% of the data. So the box in a box and whisker plot is telling me about half of my data. Specifically, it's telling me about the middle half of the data. So tell me about half of the group that we sampled, and I want to know about the middle half. I'm not necessarily interested in the smallest or the biggest. From the minimum up to the edge, that's 25% of the data. And from the box over to our maximum, this is the last 25% of the data. So I've got 100% of the data accounted for. Looking at this right here, if I know that from here, my minimum 57, up to here, Q3, 66.5, this is 75% of all of the data. I know if I looked at a histogram of this, most of the data is going to be over here. That's 75% of it. The last 25% of the data is spread out from 66.5 up to 77. So I see this long whisker here. That would be like a long tail on a histogram. Outliers. I told you we're going to have a definition for outliers. Yes, Amy?
So, can you define like the skew or anything for this type of?
Yes. I would say that this one has a right skew. Absolutely. Because I have a much longer whisker on this side, that's where my tail would be. So this would be right skewed data. You can absolutely tell shape from a box and whisker plot. Yes?
This is kind of going back to when you were finding the medians for like for the Q1, Q3. When you like didn't count 63, did you count at least one of them because you're sensitive to?
Yes.
So from both sides you counted one of them, or just
No, just the one side. I'll go back and look at that with you. So this one right here did not get counted at all. So when I was calculating Q1, it was only the things smaller than this. When I was calculating Q3, I took the top one from there and everything to the right of that. Yes. Yep. All right. Interquartile range, we talked about that. Outlier, let me go back one here. An outlier is a data value that's way too small or way too big. So we want to determine whether or not there are any outliers here in this data. Here's how we calculate something that's way too small. It's going to be Q1 minus 1.5 times the IQR. Way too big is Q3 plus 1.5 times the IQR. What was our Q1 again? 61.5 minus 1.5 times, what did we say our IQR was? 5. Pop that in your calculator for me. 61.5 minus 1.5. What do we get? 54. Were any of our data values that were collected smaller than 54? No. No data is smaller than this. I'm going to push homework to being due on Wednesday, by the way. So there are no low or small outliers. Then we're going to do the same thing, but with Q3. What was our Q3 again? 66.5. Instead of subtracting, I'm going to add 1.5 times our IQR. So 66.5 plus 1.5 times 5 would give us 74. Were any of our data values above 74? Yes. 77 is higher than 74. So we have one large outlier. Yes. You're talking about the box plot? Where we crossed out for mean and median? Or sorry, not mean, but median and Q1 and Q3, yes. All right. Have a great rest of your day. If you guys want to pick up a test review on your way out the door, it's right here in the right-hand tray. You can grab that. Homework's going to be due on Wednesday, so you have an extra day, because I want to talk about this just a little bit more before you turn homework into me. Yeah, you can grab it a different day. That's fine. I just wanted to make them available to you today.